Hello students. So last time I completed the theory of machines. Now let us do few numericals on it so that it will make the concepts further clear. First you should learn the various formulas. Mechanical advantage is equal to load upon effort. Velocity ratio is distance moved by effort upon distance moved by load in the same time. Efficiency is mechanical advantage upon velocity ratio. Work input is equal to effort multiplied by distance moved by effort, and work output is equal to load multiplied by distance moved by load. Work output would be equal to or less than work input. It would be equal to work input in case of ideal system. Practically, work output would be less than work input. The difference is due to energy loss due to friction. Work input, output or energy are measured in joules. Okay. Now let us do sum number 1. In sum number 1, he is only checking whether you know the formula or not. If you know the formula, the sum is very straightforward. Let us read the sum. He says a load is of 800 Newton. So load is given. Load is lifted through height of 4 meter. So I know that I am lifting the load through height of 4 meter in 10 seconds by applying effort of 1000 Newton. So effort is 1000 Newton, load is 800 Newton. So first part is mechanical advantage. What is mechanical advantage? Mechanical advantage is load upon effort. So you put the values, you will get the answer. Okay. So you can see mechanical advantage is load upon effort. So the load is 800 Newton, effort is 1000, so you get 0.8. The next question is what is the velocity ratio? Velocity ratio is distance moved by effort upon distance moved by load in the same time. Now, there is only one single fixed pulley. In a single fixed pulley, what is the velocity ratio? 1. So, because velocity ratio does not change, so velocity ratio is equal to 1. So no calculation. But in case he asks what is the distance moved by effort, we will say it is also 4 meter because velocity ratio is 1. Then third is efficiency. Efficiency is MA upon VR. So 0.8 upon 1. If I multiply by 100, I will get as 80%. So this is my efficiency. Then work input. What is work input? Effort into distance moved by effort. How much is effort given to be? Effort is given to be 1000 Newton, and distance moved by load is 4 meter. So distance moved by effort will also be 4 meter because VR is 1. So work input is 1000 into 4, and work output is load into distance moved by load. So it is 800 into 4, so that is 3200 joules. So the difference is due to energy loss due to friction. So the question is why pulley is used? Because we are not having any velocity ratio or non-mechanical advantage. It is used so that effort can be applied in convenient direction. So this is why we are using the pulley. Is it okay? You note down. I will give you 2 minutes. We'll go to next sum. So next sum, he says in a compound pulley system. So you should know the meaning of compound pulley system. Compound pulley system means it is having one fixed pulley and one movable pulley. Its velocity ratio is 2, mechanical advantage is 2 in case it is 100% efficient. But in this sum it says effort is 600 Newton and load I am raising is of 1000 Newton. So what is my mechanical advantage? Load upon effort. So mechanical load upon effort, so 1000 upon 600, so this is my mechanical advantage. Had this compound pulley system been ideal, means 100% efficient, then I should have got mechanical advantage of 2. Because for a compound pulley system, we have learnt it has mechanical advantage 2. But it is 1.66 because some energy is lost due to friction. Then he says, what is the velocity ratio? Distance moved by effort upon distance moved by load. So that has to be 2. Isn't it? As I told you, velocity ratio does not change. So velocity ratio is 2 as it is having one movable pulley and one fixed pulley. Efficiency. Then efficiency is mechanical advantage upon velocity ratio. Mechanical advantage is 1.666 and velocity ratio is 2 multiplied by 100 to get in percentage. So you are getting 83.3% as the efficiency. State the pulley to which the load is attached. Load has to be attached to the movable pulley. Then only when the pulley will get lifted up, the load will go up. Why fixed pulley is used? Fixed pulley is used to so that we can apply the effort in downward direction, convenient direction. Is it alright? This was explained to you in the first session when we started pulleys. Is it alright? So then we'll go to next sum. Now these sums are gradually all are easier sums. This in a block and tackle system has velocity ratio 3. So when velocity ratio is 3, so means how many pulleys are there? So there are 3 pulleys. When there are 3 pulleys, then always lower block has 1 pulley less. So lower block will have 1 pulley and upper block will have 2 pulleys. A man exerts a pull of 100 kg. So this man is exerting. So this is the effort. So effort is 100 kgf. What is the maximum load that can be lifted? Efficiency is given to be 80%. So the efficiency is 80%. Velocity ratio is 3. Efficiency is given to us. So we will write the formula of efficiency. Efficiency is MA upon VR into 100 because we are getting 80%. So this will give a mechanical advantage as efficiency multiplied by VR upon 100. Efficiency is 80, VR is 3. So if you calculate, you will get mechanical advantage as 2.4. Had there been no energy loss due to friction, means the system would have been ideal, then I would have got mechanical advantage as 3. But now it is 2.4. So what is mechanical advantage? Load upon effort. I have been given effort, so I will get the value of load. So load would be MA multiplied by effort. So load is 2.4 multiplied by 100. So that gives 240 kg. So this is the maximum load I can lift. See, now man is giving only 100 kg force, but is lifting 240 kg. He is only using compound pulley system. Then what is the next part? Effort is moving at its own 90 centimeter. What is the distance moved by load? So velocity ratio, write the formula. Velocity ratio you know is how much? It is 3. We are given distance moved by effort. So I know this numerator. So this is 90 centimeter. This is 3. So when this will take this on other side and velocity will come here. So 90 upon 3 will give me 30 centimeter. So load would move less. 30 centimeter. Is it alright? So in case you know the theory perfect, you can easily do the sums. So in doing the sums, now the theory is also becoming perfect. Both goes hand in hand. He says draw a diagram of combination of two movable pulleys and one fixed pulley. So movable pulleys are 2. Movable pulleys are 2 and fixed pulleys is always 1 in combination. So my velocity ratio and mechanical advantage would be 2 for ideal system. Otherwise velocity ratio would be 2, mechanical advantage would be less than 2. So last time I showed the diagram of 3 movable pulleys. You remove 1 movable pulley, you can draw this diagram. This is homework. Okay. Then question, find mechanical advantage. Mechanical advantage is equal to velocity ratio is equal to 2 raised to number of pulleys, so 2 raised to 4. So for ideal system. So efficiency of this system is 100%. Can common pulley have velocity ratio of 6? See, velocity ratio is 2 raised to velocity ratio is 2 raised to n. So if n can be 1, so I can have 1 movable pulley means 2. If n is 2, it is 2 raised to 4. N is 3, it is 2 raised to 8. So I cannot have velocity ratio of 6. My velocity ratio is always 2 raised to n. Is it alright? So then we'll go to next one. Now in this sum is of a block and tackle system. I have given you one sum of each pulley system. So the block and tackle system has 4 pulleys. So means 2 in the upper block, 2 in the lower block. A man exerts a pull of 200 kg. So this is the effort given by man. He is lifting load of 600 kg through a height of 5 meter. So we have to calculate MA, VR and efficiency. Velocity ratio is 4 as number of pulleys are 4. Distance moved by load is 5 meter. So what will distance moved by effort would be 5 into VR. Effort will move longer distance, no? Because velocity ratio is distance moved by effort upon distance moved by load. So distance moved by effort would be distance moved by load into velocity ratio, that is 20. So I know the distance moved by effort as well as load now. Now what is mechanical advantage? Load upon effort. Load is 600 kgf because I am lifting the load of 600 kg. So the downward pull is 600 kgf and effort is given to be 200 kgf. So mechanical advantage is 3. Now efficiency is MA upon VR into 100. Mechanical advantage I got 3. Velocity ratio is 4 because there were 4 pulleys. So I am getting 75% as efficiency. Now work input I am supplying. So effort into distance moved by effort. Work output, machine is doing the work. So machine is lifting a load. So load multiplied by distance moved by load. Both the things I know. So I will get the answer. 200 kgf is the effort and 600 kgf is the load. Why multiply by 10? They are in kgf. So to get in Newton, I have to multiply by G. So G I am assuming to be 10. So I have assumed G. I am assuming G equal to 10 meter per second square. So this is my G. Because my force has to be in Newton, then only we will get in Joule. And 20 is the distance moved by effort. Because distance moved by load is 5, velocity ratio is 4,
Here I have calculated distance moved by effort is 20, so this is that 20, and distance moved by load is given. So so in this manner we can calculate work input and work output. So typically I have done one sum of all type of pulley system. I hope you have understood. You should revise the theory, do the numericals, solve numericals given in the reference book. With any difficulty you can ask us. Thank you. So that completes the chapter of machines.